Hello friends, today we'll be discussing about a very important topic, that is normal distribution. In fact, almost all the human attributes like height, weight, intelligence, etc. follow the normal distribution on. It is very interesting that this mountain-like figure forms the basis of every statistics which you perform in the social sciences and behavioral sciences. The normal distribution curve is also known as normal probability curve. The basic understanding of this curve and the Six Sigmas help us to solve different problems related to behavioral sciences, the basic properties of normal probability curve, and the basic characteristics of normal probability curve help us to understand the population and sample distribution in better way. So for any higher education student or for a potential researcher, the understanding of normal probability curve is very much essential. So in this particular video, we will understand the concept of normal distribution, the normal probability curve, and the very basic characteristics of normal probability curve. So keep watching. Okay, then let us begin. Observe the four graphs carefully. All these graphs are showing results of findings on human attributes like memory span, height of individuals, and also the IQ distribution. If we observe the figures or the graphs carefully, in all these graphs, majority of the frequencies are lying in the middle of the curve. That we can see in all the curves that majority of the frequencies are in the middle. That is, people's having average height, average memory span, and average IQ level are maximum in number. But as the attributes measure goes on increasing, that is, people having the high IQ level, people having the high memory span, or people having maximum heights, the frequency seems to taper off. That means it goes on decreasing. It also happens when the attributes measures are towards the lower side. That is, people having less height, people having less number of memory span or lesser memory span, or people having less IQ, the frequency distribution shows that the number of peoples are very less in number. This is what I mean to say about normal distribution behavior. That is about all the attributes of human behavior like weight, height, intelligence, etc. behave like this. That's why it is called as normal probability curve, because it is the tendency of human behavior as reflected in real life situation. If we observe this curve carefully, we can see that when we divide the curve from the middle by putting a perpendicular line AB, then we can see that the entire curve is divided into two equal parts of 50% area in both of the sides. Also, we can see that the mean lies at the center of this curve, that is at the highest frequency level, and joining the x-axis, we can see that on the x-axis the mean lies. Also, the baseline can be divided into Six Sigma distribution. It has to be understood that almost all the frequency lies in between these Six Sigmas. That is 3 sigmas towards the positive side and 3 sigmas to the negative side of this curve. And we can see that the mean of normal probability curve is 0. So these properties of normal probability curve is used for studying various problems related to social science and research in education and in behavioral sciences. We can also see that 68.26% of the cases lie in between minus 1 sigma and plus 1 sigma. Similarly, there is also certain other range of frequencies lying in between different sigma distribution. For a potential researcher in the field of social science, he has to understand this normal probability distribution and this normal probability curve so as to solve problems related to social sciences and behavioral sciences, and it's also helping to understand his problem in better way and to solve these problems in most appropriate way. Okay, now before seeing the entire characteristics of the normal probability curve and its different application, let us see its equation. The normal probability curve equation is given by y equal to n divided by sigma root over 2 pi multiplied by exponential e to the power minus x square by 2 times of sigma square. Let us see what these symbols are in this equation. Here, x are scores expressed in deviation form laid off along the baseline of x-axis. Y is the height of the curve above x-axis or baseline, and is the number of observation. Sigma is the standard deviation of the entire distribution. Pi is 3.1416 ratio of circumference of a circle to its diameter, and E is 2.7183 base of Napoleon system of logarithm. So the equation is little complex, but once we start using it, all becomes very simple. Okay, now we will be seeing about properties or characteristics of normal probability curve. Normal probability curve was both derived by Gauss and Laplace. In honor of Gauss, this curve is also called as Gaussian curve. They also term this curve as curve of error, where error means that the deviation from the normal behavior or deviations from the mean. As we can always see that as the deviations from the mean increases, the frequency seems to be very less. So as we can see that the greater is the deviation of observation from the mean, the frequencies of occurrence becomes very less. Well, the second property of normal probability curve is we can observe that the height of the curve declines symmetrically in both the directions from the maximum point. You can see that the height of the curve declines symmetrically in both the direction from the maximum point or maximum occurring frequencies. So this is the second property of normal probability curve. The decline is symmetrical in both the directions. So in the right direction and similarly in the left side direction, the decline is in the same way. The third property of normal probability curve is that the shape of this curve is bell shape. The curve as it is visible here is symmetrical and bilateral from the center as the reference to the line segment AB. We can see that the curve is bilateral and symmetrical. We can see that it is a bell-shaped curve. We can see here it is a bell-shaped curve. And we can see that 50% of the case, the entire cases of 100% lies in the right side of the mean or towards the right side of the line segment AB, and similarly the 50% of the remaining cases lies in the left side of this line segment AB or to the right side of this curve. The fourth property of the normal probability curve is that the mean, mode, and the median of the normal distribution curve coincides or fall at the same point. This point is represented by 0. This makes it clear that the mean of the normal probability curve is 0, the median of the normal probability curve is 0, and the mode is also 0. As we can see that the maximum point occurs at the point 0 only. This is the maximum point, so it is an unimodal curve. So the mean, median, and mode of this curve is 0. Now we will be discussing about the fifth characteristics of normal probability curve.
That is, as we can see that the shape of the curve changes its directions from being convex to concave in both the direction, from convex to concave at a particular point in both the direction. You can see in the figures. And this point is called as point of influx. We can also see that if we drop a perpendicular from this point of influx, as it is dropped in this particular figure, we see that this perpendicular curves in the x-axis at a particular point, which is one standard deviation in both the directions. That is plus one standard deviation, and in the other side minus one standard deviation. So the point of influx occurs at the same distance from their middle point. And we can also say that the height of the ordinate at the point of influx is same in both the directions. So this is the fifth property of normal probability curve, that the direction of curve becomes convex to concave at a particular point, and this particular point is known as point of influx, and the point of influx occurs at plus minus one standard deviation in both the directions. So this is the fifth property of normal probability curve. The sixth property of normal probability curve is that the normal curve is asymptotic to the x-axis. The curve height continues to decrease on both the direction, that is from the maximum point or maximum height of ordinate to both the direction. It goes on decreasing on both the direction, but it never touches the x-axis. That is, it extends and goes on decreasing up to plus infinity to minus infinity on both the sides, but it never touches the x-axis. So the nature of the curve is that it is asymptotic and it never touches the x-axis, and it goes on decreasing in both the directions, starting from the highest point of ordinate from the middle. The seventh property of normal probability curve is that the maximum ordinate occurs at the center at the point 0. As we can see in this figure, at this point the maximum height occurs, and the height of this ordinate is 0.3989. So ordinate at point 0 from the formula which we have learned in the earlier part of this video is 0.3989. So the seventh property is that the height at this particular point 0 is 0.3989. Now let us see the eighth property of normal probability curve. As the curve never touches baseline, hence we start with the mean as starting point of the curve. Further, SD are used or sigma are used as unit of measurement for the deviations from the mean. So we can see that these sigmas plus 1 sigma plus 2 sigma plus 3 sigma are being used to measure the deviations from the mean, which is represented by 0 in this particular normal probability curve. And this sigma extends from 3 standard deviation or 3 sigma in the right hand side and 3 sigma in the left hand side, and thus we can see that the curve extends from the mean. The curve extends from minus 3 sigma to plus 3 sigma, that is in total 6 sigma divisions. The ninth property of normal probability curve is that the percentage of cases falling in successive standard deviations in both the side of the mean is fixed and are equal. You can see the figure that the percentage of cases in both the sides in between two particular sigma distributions are fixed. You can see that 34.13% cases, and in the right side also 34.13% cases. Similarly, 13.59% cases, in the left side also 13.59% cases. So this particular percentage of cases in between two particular sigma distributions are equal. Let us understand this property in details. As you can observe from the figure, the total area covered is taken as 100% of the frequency. Okay, let us understand this property clearly. We can see that the overall area under the curve can be treated as 100% of number of cases. That is probability of occurring of the cases in between this particular curve or in between minus 3 sigma to plus 3 sigma is about 99.73% cases. Now we can see that in between mean and plus 1 sigma distribution, 34.13% of the cases false. Similarly, in between mean and minus 1 standard deviation, 34.13% cases false. So, the number of cases or percentage of cases in both the direction in a particular sigma standard deviations unit in both the sides are fixed. In this case, 34.13% cases false in both the sides in between one standard deviation units, that is in between plus 1 sigma distribution and minus 1 sigma distribution. The total number of cases falling is 68.26% cases. Again, further, if you see that in between plus 1 sigma and plus 2 sigma, 13.59% cases false. This also happens when we see the number of cases in minus 1 sigma and minus 2 sigma. Similarly, here also 13.59% cases false. So if we see together in between minus 2 sigma to plus 2 sigma, 95.44% of the overall cases false. Now if we go from plus 2 sigma distribution to plus 3 sigma distribution, we see that 2.14% cases false, and similarly in the other side, the other 2.14% cases false. So in between, if you see minus 3 sigma distribution to plus 3 sigma distribution, overall 99.73% cases false. So as we have discussed earlier, in between this 6 sigma, about 100% cases, or approximately we can say that 100% cases, exactly it is 99.73%, but it is all about 100% cases falls in between minus 3 sigma distribution and plus 3 sigma distribution. We can also see that the remaining cases falls beyond minus 3 sigma distribution. We can see here, and in the right hand side also we can see here. So overall we can say that percentage of cases falling between two particular sigma distribution in both the directions are fixed, and it is also clear that in between 6 sigmas, that is from minus 3 sigma to plus 3 sigma, about 99.73% cases or almost 100% of the cases false. So this is one of the important characteristics of normal probability curve, and it is used for solving many problems based on normal probability curve. So you can pause this video, you can rewind this particular section, and you can understand this particular distribution of percentage of cases under the normal probability curve, and under the different sigma you can see that percentage of cases falling. It will help you to solve many problems related to NPC. The 10th property of normal probability curve is that the scale of x-axis in normal curve is generalized by z deviates, or in terms of z units. Z is given by, or z can be obtained by the formula z equal to x minus m by sigma, or when mean equal to 0, then z equal to x by sigma. So these particular z deviates or z scores are used when we solve different problems related to normal probability curve. So this is also one of the basic property of normal probability curve. Another property of normal probability curve, or the 11th property of normal probability curve, is that the curve is totally symmetrical, or the curve is perfectly symmetrical in both the directions. In other way, we can say that this curve is not skewed. The skewness of this curve is zero. About skewness, we will be learning in the latter part of this particular video, but we can understand that the curve is totally symmetrical in both the directions. The skewness is not there. It is neither positive skewed nor negatively skewed. Normal probability curve is having skewness 0. Another property of normal probability curve is that the normal probability curve is a smooth curve. It is very much a smooth curve. You can see that it is a smooth curve. It is not a histogram. You have seen a histogram how it is not a smooth curve. So it is a smooth curve with very moderate peakiness. This is the peakiness. It is not very highly peaked or nor very low peaked. So the peakiness of this particular curve is moderate, or it is also, in other terms or in the terms of statistics, we can say that the kurtosis of this particular curve is 0.263. So we can say that the kurtosis of a normal probability curve is 0.263. So this is the 12th property of normal probability curve. So we have learnt about different properties of normal probability curve. Now, before closing this video, we will learn a little bit about skewness and kurtosis of a particular curve. Now, skewness refers to distortion or asymmetry that deviates from the symmetrical Bell curve or normal distribution in a set of data. If the curve is shifted to the left or to the right, it is said to be skewed. We can see this particular figure. This particular curve, these are not bell shaped. This particular is positively skewed, and the last one, this one, is negatively skewed. This is the middle one is the bell shaped curve. It is a normal probability curve, normal shape. But these two particular curves are not bell shaped. There is certain distortion in its symmetrical structure. Curve is shifted little bit towards left or right, and this is called as skewness. So as we have talked, what is positive skewness or what is positively skewed curve? So positively skewed curve is that when the curve is tailed in the right side, you can see the tail is in the right side. Here the median and the mean will be in the right side of the mode. So this is the figure of a positively skewed curve. For example, we can take the example of very hard examination. If an examination is there where the questions were very hard, then this type of curve used to occur. As we know that if the test will be harder, then maximum of the frequencies will lie in the left hand side. So students having low score will be more in the left hand side, and the people having or the students having high score will lesser in number and they will occur in the right hand side. So this is the example of positive skewness. Similarly, if you see the income distribution, if you can see the income distribution, it is also a case of positive skewness. You know that the highly paid people are very less in number. The frequency of people having very high income are very less in number, but the people with having low income category, at least in our context, in our country, the people having average income or low income are very big in number. So these two are examples of the cases where positive skewness occurs. Now what about negative skewness? So negative skewness is the case where the maximum frequencies lie in the right hand side, and in the left hand side very few frequencies occur. So you can say that the tail is in the left hand side. As it is defined negatively, skewed is that when the curve is tail in the left side of the curve. Here median and the mean are towards the left of the mode. For example, if we see the previous example where we took the example of very hard case, if we take an example of very easy case, then we know that the people or the students scoring very high marks will be maximum in number, but people having very less marks will be very few. The second example is about distribution of age of death. We know that the people dying age is when the age is very high. So it happens in the right hand side. And if you see the people dying in the low age group, that is in the age group of 20, 10 or 5, it is very less in number. So distribution of age of death is also an example of negative skewness. Now we will learn a little bit about kurtosis of a curve. The kurtosis of a distribution refers to its curveness or thickness. The distribution may have the same mean and the same variance and may be equally skewed, but one of them may be more peaked than the other. A normal curve have a kurtosis value equal to 0.263, which we have discussed in the earlier part of this particular video. Now you can see the figure. You can see that three curves are there. One is in blue line, other one is in black line, and the third one is in the red line. This particular black line curve is our normal probability curve, and it is called as mesocrutic. So it has got the kurtosis value of 0.263. Now when the kurtosis value of a curve is more than 0.263, or when it is more peaked, you can see this blue line curve, then it is called as leptokrutic curve. And when the curve is less peaked, then you can see this red line curve. This is the case when the kurtosis value is less than 0.263. Then the curve is less peaked or plateaued and is called as platycrutic. So this red curve is called as platycrutic curve. Our normal distribution curve is mesocrutic curve, and if it is the thickness is more than that one, the kurtosis is more, then it is called as leptokrutic curve. So we should be knowing about our mesocrutic curve. It has got the kurtosis value of 0.263. So in this particular video, we have seen basic fundamental properties of normal distribution. What is normal probability curve? What are the different characteristics or properties of normal distribution curve? The basic understanding of normal probability curve, the Six Sigma, and the different characteristics of normal distribution will help us in solving different problems related to social sciences. The fundamental understanding of normal distribution and its characteristics will help us to understand the sample and population characteristics, its distribution, and the related problems based on sample and population distribution and characteristics. For any researcher, the basic understanding of normal probability curve is essential. So I hope this particular video will help you to understand normal distribution. In the upcoming videos, we will use the characteristics of normal distribution in different problems, and in terms of solving those problems, you will understand how this normal distribution is essential for all the researchers, for all the higher education students. I hope you all have liked this particular video. So please subscribe to this channel and like this particular video, and also provide constructive feedback. You can contact me in the given address, in the given email ID and mobile number. So keep watching. Thank you.